Welcome to the Algebra 2 Structure and Method textbook series. This lesson is from Chapter 5, Section 6, Sums and Differences of Rational Expressions. So in today's lesson, we're going to learn how to add and subtract rational expressions. Before you start the lesson, you should know how to add and subtract like and unlike fractions and factor polynomials. Let's get started. Let's begin with a warm-up to find the least common multiple for each set of terms. Pause and restart when you're ready. I'll show my answers now. How did it go? Okay, so just remember that the least common multiple, it's the highest power of all factors between expressions. So let's move on to the lesson. When we add or subtract fractions with like denominators, we can simply add or subtract their numerators and write the result over the common denominator. This is formally stated in the addition and subtraction rule for fractions. So to extend this rule to expressions involving fractions, we want to write each as a single fraction in simplest form. For our first example, we have two fractions with like denominators, so we just need to combine our numerators and simplify. For part A, my numerator becomes 4 plus 13 minus 7, which is 10. 10 over 15 reduces to 2/3, and I'm done. Part B is similar. We just need to be careful of the subtraction sign. My numerator becomes 3x squared minus 8 minus the quantity x squared minus 9. When I simplify that, I'm going to distribute that subtraction sign through to get 3x squared minus 8 minus x plus 9, and then simplify. I can't factor anymore, so I'm all done. Now, if we have different denominators, we want to find the least common denominator of all the fractions, rewrite the fractions with the LCD as the denominator, and then add or subtract and simplify our result. In example 2, we do not have like denominators, so we need to make some small adjustments. First, I'm going to factor my denominator so I can see what my LCD is. I take the highest power of each factor to get 2 times 3 squared times 7 equals 126. I rewrite each of my fractions over 126, my new LCD, and then I go back and do the same math that I was expecting to do before. Oh, I'm covering it, but the final answer is negative 100 over 126, which simplifies to 50 over 53. Negative 50 over 53, sorry. Or 63. Pause the video and give this one a try on your own. We do not have like denominators, so we need to find an LCD. I'll get started. Okay, 2 cubed times 3 times a squared b squared is 24a squared b squared, which is our LCD. So I'm going to rewrite each fraction over 24a squared b squared. And then I'm going to go ahead and do the usual math I was going to do before. And my final answer is 4b squared minus 12ab plus 9a squared. Now keep in mind that this can actually be factored, but because it doesn't cancel at all with the denominator, it's not a necessary step. Our final example is similar, but we have to do a little bit more work. The first thing is we don't have like denominators, so we need an LCD. I'm going to factor each denominator first, and that tells me my LCD. I'm just taking one of each factor, basically. I rewrite my fractions over those LCDs, and then I combine my fractions again. My final answer is x minus 9 over my least common denominator. So what's a common error when you're adding and subtracting rational expressions? Turn to your classmate and let them know. I'll see you in the next video.